Alright, our last notes now in Chapter 6 for parallelograms or quadrilaterals is actually a better way to say it. So these polygons with four sides. We look at the last two conditions here, trapezoids and kites. And we're going to look at what they mean and some basic understandings of if we know it's a trapezoid, what is true. If we know it's a kite, what is true. So first of all, so if you have a trapezoid, we know for one thing it's a quadrilateral, right? But then we also know that one pair of the parallel sides, or one pair of the sides, are parallel. Okay, so if we look at this one here, we have this one, these two are parallel, these are not. Okay, so and then we call those parallel sides bases. Okay, and then we call the angles along these vertices base angles. Okay, and also a trapezoid. So one pair of the sides are parallel, and then also the legs are not parallel or non-parallel. So we can look at this. Legs, they're not parallel, just the bases. Okay. Now there's some theorems that go along with it. Okay. First of all, a trapezoid can be isosceles, and which means two of the sides are congruent. Okay. Doesn't mean they're parallel, just means they're the same length. Okay. And we can tell that a trapezoid is an isosceles trapezoid if each pair of the base angles are congruent. So we got this pair is congruent, this pair is congruent, and this makes it the two sides that are equal, isosceles trapezoid. That's one thing. Each pair of the base angles are congruent, then it's an isosceles trapezoid. We then keep going. We can also say if a trapezoid has one pair of congruent angles, it's also an isosceles triangle. So we have these are congruent, right? So then we know if these angles are the same, that tells us these are the same, so that means it's an isosceles as well. Okay. One of the last things here for trapezoid, it's also an isosceles trapezoid if the diagonals are congruent as well. So these are same length. So again, just to review, diagonals are congruent, that means it's isosceles trapezoid. If one pair of congruent angles on the base, then it's an isosceles trapezoid. And then if we go back as well, if we say that each pair of the base angles are congruent, it's also an isosceles trapezoid as well. So there's also something that goes along with this, and it's a mid-segment of a trapezoid. So a mid-segment is just a segment that connects the midpoints of the legs. So here we have the legs, this mid-segment comes in and it divides this equally to where both of these lengths are congruent. Keep going. We then look at the theorem for that. The theorem says these are parallel. This mid-segment, I'm sorry, I'm looking at the name here. So this mid-segment, that's what I meant, I don't know how to put that. But mid-segment is parallel to each base, and its measure is 1/2 the sum of the lengths of the base. So if we have this mid-segment, MS, then we know two things. It's parallel to these, has to be, and it's also 1/2 the length of the total length of each of these bases on each side. So then we can kind of write this idea. So if BE is a mid-segment, this right here, then we know that AF and BE are congruent. AF, BE, they're congruent. We also know BE and CD are congruent or parallel. So AF here, so this is a mid-segment, AF is parallel, BE is parallel. We also know BE is parallel to CD. And then we also know that it's half the total length. So then we can just write it out. BE is equal to 1/2 of AF, this distance, plus CD. Okay, that's a really good theorem to remember. The last shape you want to look at for this entire unit is something called a kite. And a kite is just another quadrilateral with exactly two pairs of consecutive congruent sides. But also, opposite sides are not parallel. So here we have these two are congruent. These two are congruent. That makes it a kite. Okay, two pairs of consecutive congruent sides. So this is your one pair, this is your two pair, and they have to be consecutive. They have to be touching each other. So that's what makes this a kite. These are congruent, these are congruent. Okay. There's some theorems that go along with kites that we can need to remember, things that are true about them. So it says here, if a quadrilateral is a kite, then its diagonals are perpendicular. So if we did this, so if we label this A, B, C, D, if we went from D to B, and then A to C, these would be perpendicular. And if we did like a slope on these lines, we would see that they are perpendicular. It would be a good thing to remember on these problems. And then also, if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. So here's your kite. So we got to have either this angle here are congruent, or it could be these as well, but only one pair. Okay, and that's kind of our notes on trapezoids and kites, and that's good. So remember, this is a trapezoid. It has two sides that are parallel. The other sides are called legs. There's some truths about them. They could be isosceles trapezoids. There's certain conditions to remember for that. They also have mid-segments where this cuts these two legs in half perfectly. So these are congruent, these are congruent. And then we have some theorems again that go along with that, so that we know that these are all parallel to each other. And then also this is 1/2 the total distance of those when we add them together. So add those to your notebook, and I'll see you in class.